we have a mass here, okay? And this mass basically creates a let's say virtual funnel. It's not real funnel, it's just matter of speed. For sure, in every direction. And what is happening here is, let's say, this is eating up Fabrikas. Therefore, there is a rate in total rate for eating up Fabrikas per second. Now, when we want to calculate the gravity, like gravity, if something is here, an object is here, and we calculate the gravity based on basically number of quantity of Fabrikas that is eating up, we can calculate the acceleration of this object. Why? It is observer acceleration, it's not actual acceleration. Why it is observer acceleration? Because this framework is moving to the framework, the space and time itself is moving inside this massive object. So basically the whole X, Y, and Z, the framework is moving, not the object. So when the framework is moving, we feel the acceleration. Now, when we calculate this acceleration based on the quantity, let's say consider this a virtual funnel, based on the quantity of the eating up or destruction of Fabrikas, we will come up with G. So G will be the result.
The acceleration, yeah.
Yes, G will be the result of this calculation. Let's say these are Fabrikas. As you can see, it's getting more and more and more as long as we are going to the deeper space. Therefore, the speed here, when we are actually taking everything from funnel from this part, the speed here is way more than here.
Yes.
It has that R2 relation. So here is slower, here is faster. The acceleration is that. So it is accelerating. And what is the result of our equation? The constant that we are making is G. For example, in Earth.
G is acceleration.
Or yes.
Yeah. G is
So
function
it's
of
not it's the result of our equation. G will be the result, not part of our equation.
Yeah, small g. Yeah.
Exactly. A small, like also big G. Why not big G? Because big G also is per kilogram. How many Fabrikas is using up?
Okay.
And then we can
small g, you can write what is.
yes, big G. Yes. Anyway, what is gonna happen? We are gonna calculate the quantized Fabrikas that is eating up by space and like by the mass, by the matter. And what is gonna actually come up is that calculating this. Now, what is the difference between this and Newtonian law? In very, very, very larger scale. Because in very larger scale, what will happen? This object, massive object, is eating up Fabrikas in all directions, independent from any other second object. It doesn't matter if it has a moon or sun or whatever, it's eating up no matter what. Therefore, the total calculation for this in long distance will be very different than this calculation in the short distance. So in short distance, it's like this. In large distance, the whole basically Fabrikas, that is this massive object, is eating up in every direction in all directions
Yeah.
will be like exactly like a sink. Exactly like a sink.
And then velocity will be like that.
Yes.
It will be less and less as you go far. But eventually,
Even in the far, yes, even in the far it has the effect. And in the far, it will be accumulated. So basically, the whole number of fabrikas that Earth is eating up per second in all directions will be calculated. Like for example, we call it Earth's fabrika eating power, for instance, or destruction power. What will happen? It will be X, and because it is happening in all directions. And then we calculate it plus Y and plus Z and plus all of the objects that are available in the galaxy, and that number will be way bigger than a normal, basically, calculation just based on Newtonian or even general relativity's gravity. Because this is quantized, and it is plus, and it doesn't matter, you know, the distance in this equation will be Vegas. Okay. Now, this will be answer to dark matter, absolutely, because this was the expectation that they have about dark matter, and it will predict all of the Newtonian law, and it will predict a space-time bending of general relativity as well. Why? Because if it is eating like a space-time, quantized, what will happen? Let's say it is eating up, right? At the same time, it will create the curvature because it's eating up, right? It will create a curvature that is predicted in general relativity completely because it is eating up from every direction, and that curvature actually it is in all directions. The one that we see in images is not exactly because that's 2D. This is 3D, curvature in every. So lensing, gravitational lensing, all of the predictions of general relativity will be applicable as well. So this is one thing. There is one more thing which is very important. When this process continues for millions of years or billions of years, what will happen? You remember we talked about a scar in the face of, for example, a child. It will remain forever. Even if all of the cells are replaced, all of the molecules, all of the atoms are replaced, that scar will remain or even can get bigger. Why this is happening? Why that scar will happen? Because it will, this process, this continuous process,
until mass is there. Until mass is there.
Until the mass is there. Yes, but still, even if we remove the mass suddenly, out of the sudden, the scar, the change of the, because it ate the fabrikas more than dark energy in that point of space and time. So the scar will be elastic, kinda.
So it is more deficit than fabrikas can recreate.
Exactly. And even if because they're recreating, that shape will remain. You know, it's like a scar in the face of the child. If the child getting like growing old, that scar will remain still.
So the fabrikas are constantly created, but
in the whole universe,
but
in the galaxies, because the matter is like compact in the galaxies and like the distance, that scar will remain there, and you can see the dark matter web that we are going to actually see the video. So basically this can easily predict dark matter because dark energy is created all the time fabrikas, and dark matter means that dark energy is not created. Fabrikas are creating fabrikas, and they call it dark energy, and fabrikas getting eaten by mass in the galaxies all the time. Therefore, this will actually create the scar, make it even deeper or more bold during the time. So the time and space and reality around the galaxies, they call it a dark matter halo, will remain there, and it will move even with the galaxy. So the scar, even if you, for example, change, like just imagine like a child, like the scar can move on his face from, for example, if I have a scar here, it may move here. So it is exactly like a scar on the face of a child. Because during the time, all of the cells, everything will change, but that scar, which is change of the shape of the system, will remain. So it is completely crystal clear that how basically it will affect the dark matter. And that is not actually gravity. That's why that is the difference between this theory and general relativity. In general relativity, basically, it predicts the effect, not the root cause. So the effect is time and space bending. This is the effect. Now, how this happen? By this.
Yeah, this is one step before.
One step before general relativity, completely. So that's why all of the predictions of general relativity in every way will remain intact. There is no basically question about that. So the calculations that we are doing based on eating up the Fabrikas per second and continuously, it should create the same bending, like if you want to confirm it, the same bending. So basically if I'm eating from here, it will create, for example, let's say a bend like this with this shape. And then we should have, if we want to check the curve which is created because of this process, we should come up with the same general relativity's prediction as the bending, because general relativity predicts the bending shape.
Yeah, it's metric.
Yes. So now, when we calculate this, after that we should come up with the same prediction of the bending, like curvature degree.
Yeah, based on this short metric.
Yes.
Outside the star, there are some quantities called curvature or something.
The curvature has a degree, which is in black hole becomes infinity. Why in this case in black hole is, yes, why this case is not making a black hole infinity? Because it is quantized, like ultraviolet catastrophe. This can never become infinity. Because whatever you do, whatever you basically eat up from the Fabrikas, it never becomes infinity. Exactly like ultraviolet catastrophe, because it is quantized.
So their infinity becomes curvature?
No, the curvature never can become. That is our difference with general relativity in predicting black holes. So in extreme situations, we will have a different outcome. In general relativity, the space is smooth. It's not quantized, correct? Now, what that means, in certain point, black hole, because it's divided by C, it's divided by, it is gonna be divided by 0. In black hole, because it is not quantized, it becomes infinite, the space-time. The time will be 0, time dilation will be like maximum, and basically everything will go through the infinite system. Exactly like ultraviolet catastrophe. What happened in ultraviolet catastrophe? It was exactly the same. Ultraviolet catastrophe considered the whole wave function smooth. It means not quantized. Therefore, ultraviolet catastrophe happened. Now, when they added the quantized Max Planck factors,
energy packages were quantized.
now, so this actually shows in black hole the time passes. Very slow, but it passes. You can never reach infinity with quantized, because it's quantized. You have a number.
I have to see what corresponds to curvature there in here, or this corresponding quantity.
Yes, there is no quantity in general relativity. It is just divided by 0 in black hole.
What is there and what corresponds to here,
Okay.
to curvature.
Okay, we can actually research
It
about
would
that.
be some kind of rate of distraction, yeah? It should be proportional.
The problem with general relativity and black holes is infinity. two infinities happens in general relativity when you are calculating the space and time bending
Inside the
in the black in the event horizon.
Here inside we have simple pictures.
Yes, this is quantized. This is
Once
quantized.
Fabrik is inside, it disappears.
Yes.
And then we have kind of simple inside process.
Yes, but it can never become because we are gonna divide a quantity by quantity, and it's never gonna reach infinity because the quantity divided by quantity, which is not zero, is always written as a number. So it goes through very sharp bending, but it never becomes, the effect never becomes infinite.
Rate never becomes.
The rate never becomes infinite. So this will answer to the whole catastrophe of general relativity and black holes. That's why Albert Einstein never liked the idea of the black hole, despite the fact that it got predicted by general relativity, the black hole thing. Now in this we are going to solve it completely. So basically this will actually cover Newtonian law with a very simple equation. Newtonian law will be the result of this movement, like illusion of acceleration, and basically Albert Einstein general relativity will be also there, because when you are eating up Fabrikas in this shape, you are actually creating the bending. The more speed it has, the bending will be more.
But bending, I have to see how to correspond bending with that process.
It is easy, I will show you. Okay, let's consider this is a very
bending of 3 or 4 space, no 3 space.
Yeah, it will be 3 dimension. But anyway, just consider a ball that it has a hole here, okay? And I have balls here, okay? Actually, I have a very, very amazing example. Wow. This is our bending. Take it. Basically, this is quantized. Fabrikas getting eaten up by this.
Okay.
And after a while, you will see the bending here will get created.
On the top.
On the top, it will be bent.
Yeah, because center force. Yeah.
So the whole general relativity will be predicted by this. So this is the underlaying of general relativity.
So the top will be curved, yeah?
Yes, sure. We will put it here. You can see it started to curve.
Oh, cool.
You see?
Nice.
This is exactly theory of Fabrika. Here we go.
Show the surface.
Yes.
It's covered.
Take it. This is the bending that is predicted by general relativity as the root cause, but it is not the root cause. It is just effect. So, in general relativity, they say this bending caused the gravity.
Yeah.
What we say, the bending is very different from the gravity. This illusion of gravity is created by framework moving, not bending itself. So bending is the effect which has a full match with that move. So in general relativity, what it says is this. It says the bending caused the movement. So the bending tells how matter to move. The space-time tells how matter to move that bending. But what we say is that bending is a full match with the movement of that, but this is not the real cause. The real cause is the framework itself moving.
But now, that's a good comparison. Before we wanted to have a two-dimensional acceleration, yeah? But now I see that it is the surface of it, something like that. Sure.
No, this is actually, this is going in one direction.
One direction.
This is going through all directions.
It's not like but it's like.
It is like that bending that we have in general relativity, that the images that we see, it's like this. It's just 2D.
2D.
But this one is,
curves to this,
yes, the curvature is 3D because that one is 2D. But anyway, the real general relativity is bending in every way. So it's bending in all of the directions, not just one direction. That's how basically the lensing works, gravitational lensing works, because it's in every direction. Okay? This is exactly the theory of Fabrik. Like we can see that bending is a match. That's why the calculations of general relativity are correct. What it has, this system has two effects. One effect is changing space, time, curvature. The other effect is illusion of the movement of the object. But these two things are different in this theory. In general relativity, it is exactly the same. Predictions of general relativity is based on matching those two effects together. That's why the dark matter crisis created. Because in dark matter, these two effects will get separated from each other. The bending of a space-time in larger scale will be different from the movements of the objects. You see? These effects in the normal scale matches, like in solar system. But in galaxy, these two effects will have two different functions. So from certain point they will get separated from each other. In black hole, again, the effect will be very different because it's extreme situation. You know what happened to Newtonian law, which actually got replaced by general relativity? In extreme effect, general relativity, like the speed of near speed of light, and very large masses, general relativity had a better answer. But in normal situations, they have the same answer. Now, in very extreme situations, this theory will give the answer. And also for sure in normal situations and in semi-extreme situations. You see? Please film it. This is exactly theory of Fabrik if you want. I don't know how I have this. So basically we are like removing Fabrik.
And the particles on the surface go like that, and
yes.
Accelerate.
Yes.
So we want to describe this motion of something.
And they will accelerate. You see, this is a way more accelerated. The speed here is very less for sure. It's R2, like R2.
Yeah, the closer you are, faster you move.
The faster it moves. That is R2. I think it's very clear about what we want to say.
Yeah, interesting.
And that's how we can actually have very much Newtonian, very much bending space and time, like general relativity, fully covered. Dark matter will be fully covered. And we are going to come with a new constant, replace the G with it, because G is the result. Again, is the effect. That's why G in the larger scale doesn't work.
But here G will be the acceleration of the space, not accelerate. Yeah.
It will be effect.
And then beta will go with it. With
Yes,
space.
sure. Yes. This is a framework that's moving, not me. My framework XYZ, the whole framework is moving. The framework is moving, not me. If I'm actually like jumping and coming back, it's the framework is accelerating, not me. And for sure, I'm always fixed in my framework. Therefore, if I'm fixed in framework, I will go with my framework without any movement. I don't have acceleration. That's the framework which is accelerating. And that will answer to very, very fundamental physics questions and will create a new layer totally for quantum physics and general relativity in this case. So this is what we are defining as the first place. That's why basically when we are talking about the change of framework, like a framework itself, in large scale galaxies, we are talking about very interesting effects in the space and time. So that halo, dark matter halo, is actually the halo framework changed and shaped in different ways. The whole framework of a space-time. Okay, thank you very much.